Okay, so let's start with central angle. Are you ready? Central angle is an angle whose vertex is the center of the circle. So central angle is an angle whose vertex is the center of the circle. So draw your center as best you can. And let's just draw an angle, something like this. So this meets the definition of a central angle. Its vertex is the center. So I'm just going to write in here central angle. Let's guess. How big do you think it is? So maybe we could say 40. Let's say 40. It's fine. We'll guess it to be about 40 degrees because that'll be important later. Okay? All right. Now, arcs. We're talking about arcs. Minor arc. And I'll tell you what an arc is in a second. A minor arc, an arc is formed by an angle less than, a minor arc, I should say, less than 180 degrees. So there's a couple things I have to tell you what an arc is, first of all. An arc is a piece of a circle. Okay? So if we talk about a minor arc, we're talking about this piece of the circle here, and I have a color here. That piece of the circle that's formed by that angle, which is less than 180. So it's a minor arc. Make sense? So I'm going to put here minor arc. Because it's less than 180. I'm also going to label this A, B, and C, which will be important later. Okay, a major arc, it's an arc formed by an angle that is greater than 180 degrees. So on your picture, you could say, okay, well then the rest of this is an arc on the circle. It's greater than 180, so I'm going to call that's a major arc. All right, you've heard this word before, semicircle. Okay. An arc with endpoints that are the endpoints of the what?
Diameter.
It is the diameter because it's 180. So the endpoints of the diameter. So I used a third color for this. Maybe you don't really have to, but you could just extend your side here, your radius. You can extend your radius. And if you just want to draw it on the inside of your circle, whatever. Most of you probably know what a semicircle is. It's an arc. Its endpoints are the diameter, which we'll talk about the measure of that in a second. Okay. The measure of a minor arc. It's the measure, we call it the measure of the central angle that forms the arc, and we say the measure of arc AB. So down here, this is arc AB, and this is how you would write it. The measure, we use the M again, of arc has an arch over it, is equal to, what's the measure of the central angle that arc is formed by? Right here. What's the measure of that angle?
40.
40. So the measure of arc AB is 40. Okay?
Okay.
Sure. Okay. Then, let's just for purposes here, let's write this. Put a D there for me, will you? I should have had you do that earlier. Okay, let's talk about the measure of the major arc. It's the difference between 360 degrees and the measure of the related minor arc. So here's my major arc. This is my related minor arc, correct? So you could probably just do that in your head. 360 minus 40, what's the measure of my major arc? 320. This is how you would write it. The measure of arc, you use 3 letters usually when you have a major arc. So I'm going to say BDA. Okay, you could say ADB as well. It doesn't matter. Arc BDA, so you put this like arch over it, equals 320 degrees. All right. Congruent circles. They are congruent if they have the same radius. Okay? Same radius. Congruent arcs, if they have the same measure and they are arcs on the same circle, or they're arcs on congruent circles. So we'll take a look at that too. Now I noticed in your homework yesterday you might have come upon the symbol for circle. Did you see it? Okay, so you always name it by its center point, which is what letter here? C. So the symbol you may see like this. That means circle C. Right? Using the center letter. So, questions on any of this, because the back side of notes is really quick. It's just kind of referring to this stuff. Is this cool? All right, let's take a look then. All right, of course there's a postulate, right? Anybody remember the difference between a theorem and a postulate?
I do. One of them like proven.
Correct. The theorem has been proven already. The postulate is just kind of based off that theorem. Not that it's not true, but it's sort of the difference. Arc addition postulate. So the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. That's pretty obvious. If you have 2 arcs next to each other and you want to get the full amount, you just add them together, basically. Pretty obvious, okay? All right, identify the given arc as a major arc, a minor arc, or a semicircle, and find the measure of the arc. So, arc TQ. This is a T here. What's the measure of arc TQ? 120. What's the measure of arc QRT? So we have this whole thing here. So we would do 360 minus 120. And that equals what? 240 degrees. Now I forgot to label whether it's major, minor, or semicircle. What's this one?
Minor.
Minor. Why?
Because it's less than 180.
Because it's less than 180. What's this one? Because it's more than 180. Okay, TQR. So I'm going from here to here. If I add those two together, what do I get? 180, which makes it a semicircle. Okay, arc QS is this and this. I need this. So how can I get this piece? You can do 360 minus all of these, or you could see that this forms a straight line, correct? So I could just do these two, and that would be what? 100. So then if I add 60 and 100, what do I get? 160. And is that major or minor? Okay, TS is easy. That's 80. And what is that? A minor, right? You're getting the hang of this, I think. And then RST would be what? 180, which is a semicircle. Okay, not too bad. All right, tell whether arc CD and arc EF are congruent. And explain why or why not. So are they congruent, do you think? How come?
Because the radius is the radius is like the center to the edge.
That's more the important part. The second part, what'd you say? The 45 degrees, yeah, that they're congruent, okay? Yeah, so I would say they are congruent. They have the same measure and both on circle P. So remember, that's what it said on that theorem on the other side, right? Actually, it wasn't a theorem. It was a definition. Okay, here. Are arc CD and EF congruent in this one? Tempting. They have the same angle measure, but they are what? Are they on congruent circles? No. Since they're not on congruent circles, they are not congruent. Okay, even though they have the same angle measure. So you would say no. They have the same measure, but not on congruent circles.
Oh my god, are you kidding?
Okay, we're still looking at CD and EF. What do you think?
Yes, we don't have any of the angles, so we can't prove it. We can prove it.
It's prior knowledge.
Semicircle.
No, we don't know that for sure. But what do we know about this angle and this? They're vertical angles.
Well, how do we know that they're not veering off a little? You know what I mean? Like maybe that isn't.
Well, I know, I guess I'm making assumption that they're straight lines, but no, we can't really assume.
This is what geometry does to people. They lose their trust in you.
I looked in the book, that's what they said. Let's verify. Let's look and see. We're going to say congruent, and then I will come back to you with that. I'm going to go ask down the hall. Same measure, because they're vertical angles and on the same circle. Okay?